I'm David Foster.
And I'm John P. Want to see a $20,000 printer? Hey everybody, welcome back to another episode of Geek Beat. That might be the weirdest intro we've ever done.
Yeah.
And it's not a coincidence that you were the one who were on the show. Callie's going to blame you for that. You know that, right?
Well, yeah, this is only like my second one, and I have the weirdest one yet.
Yeah.
That's pretty impressive.
Pretty good. It begins.
Yep.
Welcome, guys. We have a special episode of Geek Beat for you today in which we are going to take a look at big-time printers. And joining us, we've actually got our buddies Mike and Tracy from Stratasys and SculptCAD.
Nice to be here, fellas.
How you guys doing?
This is awesome. This is awesome.
Happy to be here.
You brought a lot of junk with you.
We brought a lot of things to show you guys today.
Some call it junk, some call it toys, some call it our business.
Your stuff is junk, my junk is stuff.
That's right, that's right.
Models, parts.
Welcome to the show. Let's get down to business. We're here to talk about printers. And I am not talking about little like MakerBot type printers. I'm talking about things like that. The size of, that's bigger than a refrigerator in a dorm.
Much bigger than a refrigerator in a dorm. This is the Uprint SE Plus, an ABS plastic printer made by Stratasys.
So you were showing David and I these printers the other day when we went down to downtown Dallas to SculptCAD.
Yes, sir.
And what I found amazing was I was not prepared for the fact that these printers are not like the little printers we have. They fill in stuff where you would otherwise have gaps. Mm-hmm. So you handed me this skull here, but this is actually not a solid piece. I can tell it's really light.
Yeah, it's
so
hollow.
It's hollow.
Yep, correct.
But normally, you can't really just print hollow things very easily. You've got to have support material or something like that.
Well, with FDM printers, and that's fixed deposition modeling printers, you have a choice, right? You can choose to print a solid model or to save material and make your printing more faster, right? Mm-hmm. You can print it with hollowness or lighter support structure on the inside.
Okay. So what about things that you can't print? Like this one, maybe I could see if you had some internal support structure, you could get this dome here on the top. But there are certain things that you just cannot print without some kind of support. And yet, if you put support all over it, it will ruin it.
Well, it won't ruin it.
Well,
right?
it wouldn't come out as a nice finished part. So what do you do in that case?
A perfect example would be this chain that we have here. As you can see, this chain was actually printed all at one time in one print. The white obviously is the chain, the white is the support material. So when you get to sections like to hold up this particular link, normally it wouldn't have anything to bridge the gap.
Right.
So it uses a dissolvable support material to fill that gap in. When the print is completed, you put it in a wave wash station.
Now, was that high pressure wash station that we saw?
It was very similar. It uses a dissolvable chemical that actually can be flushed right down the drain, but it actually will dissolve away the support material in leaving the plastic part exactly as the way you printed it.
Okay. That's what I'm talking about. And that's what a printer like this one can do?
Absolutely, yeah. So all the FDM models that Stratasys makes have soluble support materials, and it's part of the package where you get a support material cartridge and you get a model material cartridge. The two printer heads inside blend it together. The computer control automatically takes care of where you need supports, tells the machine how much to print, and then once your gravity overhang or your assembled model that you want to make is completed, you wash it away, and you have movable parts on your models.
Awesome.
Another example with the Halo Master Chief here, as it's printing it layer by layer by layer, it has nothing to hold the arms up.
Exactly.
So what it will do is it'll build a layer all the way across, up every single layer, all the way going to the very top. And this was the, speaking of the high pressure water system, this is the printer that it was printed on. The material is like a jello, like kind of a jello substance. Hose it off with high pressure water, can go right down the drain. Perfectly clean model, ready to display, market, put into your car if it's an automotive part, whatever you want to do.
Well, you know what's deceiving is like we see plastic toys all the time, and you just assume, okay, that's got to be like a plastic toy. But you pick this thing up, and this is like mean, this is solid.
Yeah.
It's what is it? How much do you think that weighs? That's 8 pounds.
You know, like I don't know, like 350 pounds or something, about roughly, give or take. I mean, I don't know, give or take 350.
The reason Master Chief weighs so much is because there's a difference between the types of printers we make at Stratasys. The first kind we talked about was FDM. The one that he was printed on is a full color model that's a polyjet model. It's a digital material, a liquid photopolymer that cures layer by layer, but by its nature, when you spray it down, it's liquid, so the thing is completely solid. And it always will be solid.
What so he could be multiple colors? Like he could
absolutely.
be.
He is multiple colors.
Well, I mean, like
here's a perfect example with this bike helmet. So we could make every piece on him a different color out of any of these palettes, and it would print them all at one time.
What if you scratch it?
It's
like
actually
if I took
full
my knife
color.
and just gouged
it's
it.
full color all the way through.
All the way through.
Well, you know how like well, it does have it. I noticed it has the glare just like the.
Yeah.
How do you do that?
Well, the truth is there's multiple ways. It's called print orientation. And wherever you print, and you can see there's a matte finish to this, but if you look on the underside, right, it's kind of shiny.
Yeah.
And the reason is because wherever support material touches the model, it mattes it by nature.
Oh.
And everywhere it's left untouched, it's shiny, has a gloss to it. But you can restore that gloss in secondary post-processing if you want to, or make it all matted if you want to.
Like hit it with a little sandblasting or some kind of
Exactly.
chemical
Absolutely.
etching or something like that.
If you want it nice and shiny, clear urethane spray, make them just crystal
Is this
clear.
designed for like monkeys or?
Actually, that's the Trek bicycle companies, one of their helmet designs. And they're
it's
one of
prototype.
our most prolific users of our polyjet printers. They use it to design their seats, their helmets, their bikes for fit and finish, as well as sizing and compatibility with the rest of their production models.
Every toy company, every shoe company, all use polyjet type technology where you can do, shoe companies use it where you have rubber and hard plastic so you can simulate the sole of the shoe all in one.
You're telling me this joystick was printed all at one time.
At one
Move it
time.
around.
So
There you go.
it moves like a normal. It feels like a normal boot.
Push the buttons.
It's rubber. Yeah, the buttons are squishy and rubberized.
Yeah.
But this is hard. Ow, that hurt.
Part of the Connex technology allows you to print digital materials and spray them at different values, where you can have softness, hardness, color, the type of material you're wanting to build, whether it's digital ABS or a medical plastic or anything really.
So you know, one thing that I have a bigger head, so I always have trouble finding things that fit. I can see this being where you could go in and say, hey, this is the measurement of my head, print me a helmet for my bike. And
I know the feeling.
Yeah.
I know the feeling.
Custom.
Yeah,
Absolutely.
That would be cool. Everything customized.
Yeah.
So the printers you guys sell, though, this one we're looking at here was about $20,000.
It is. That's correct.
And that's kind of one of the small ones, isn't it?
It is actually. We only have one other smaller one than this. That's the Mojo unit, and then from here we go up in size. Right?
How big do they go, just out of curiosity? Like, what's the biggest one I could get?
The biggest one would print a part that would be about 3 feet long.
Yeah.
You can print an entire car dashboard. Some car dashboards are printed between 3 and 5 feet long, and depending on how you orient it, Kia uses them to actually prototype their entire dashboards.
Wow.
Inside the
Our
motor.
biggest printer is the Objet 1000. It's a 1,000 millimeter bed, right?
I just like that it has 1,000 in the name.
That
Sounds like something out of the movie RoboCop.
It is.
It's the Objet
It kind of looks
1000.
like that because it's a huge machine, right?
Yeah.
It's a polyjet machine. Biggest one on the FDM side is the Fortis 900, 900 millimeter bed.
I wonder if you could actually print a John P. in the fetal position.
Like just curl up and suck my thumb and print that out.
We can get the right
scan it.
scanners in here. We might be able to get them in.
Skull-
He's
Skullcat.
awfully thin.
Skullcat has the scanners.
How much does one of those big monsters cost?
Oh,
The
okay.
Objet 1000.
So let's say this starts off at around 800K.
Okay, so for like a cool mill, you could probably get one of those and get like some printing material.
It
and-
would be outfitted
perfect
with the
case.
works, with the printing materials, the washing stations,
Right, we
all
have
the
it
extra
all set
accessories
up.
you need to go along with it.
A
to
great
make it work.
example of where the value is with the car dashboard example. You have teams and teams of engineers creating a dashboard. They 3D print it, and they figured out they had 27 design issues. They go back, fix the design issues, print it again. Fix the design issues, print it again. Each print cost them, in the time and labor, was $150,000.
Oh wow.
So the tooling alone would have been over $1 million to create tooling to do an injection mold of a dashboard to figure out
that it was broken.
That it was broken 3 times.
Yeah.
So that's where the value comes in.
So yeah, actually that's where these sound like a lot of money, but it's nowhere near the money that's spent for an alternative process.
Absolutely.
No, it really is all about building better products faster and less expensive for companies that are in manufacturing.
Injection molding, to injection mold a little tool like this, a customer might have $15,000. With the PolyJet technology from Stratasys, you can actually 3D print injection molds. Injection mold might only cost you a few $100s.
Wait a minute.
To get a few parts out while you're investigating the whole process, getting your marketing together, when you can actually afford to get full tooling to print 50 to 100 parts a day.
Okay, so you're saying
John's skeptical.
Yeah, no, it's like processing. So like this skull, if we wanted to make it in, for those of you who don't know what injection molding is, what you do is essentially, what you do is you take a piece of metal and you carve out what you want the part to look like. So you're making a reverse in the metal, and then you have 2 pieces of it, you put them together and you squeeze plastic down into it under like high heat and pressure.
Yep.
And then it cools and you open the little thing and the part falls out.
Correct.
That's injection molding, okay?
Correct.
You're injecting the plastic into a mold and then you open it. Now, you're saying those metal pieces are typically very expensive. They could be
very expensive, and they take weeks to make, right?
$5,000.
And
they
weeks,
could be milled,
months to,
CNC, the whole terrible.
So
you're saying you could make the metal things
on
by
the flip
printing
side,
it?
right? On the flip side, if the application is right, so low temperature, low cycle, right? Or if you're doing what Tracy was talking about with the dashboards, you want to test your mold. You want to test to make sure that it's going to be the right size, the right fit of the part. You print a 3D mold, you put it inside the inserts of the machine. For low volume, low temperature applications, spray it in there, pop it out, test the fit and finish before you go to production, and spend $15,000 or $25,000 or $30,000 on that metal mold, right? So you have everything correct, everything precise, all that precision built into it.
This knife handle, and I know you're a knife guy.
I am
This
indeed.
knife handle is a perfect example. This gentleman brought us the knife to create. He had one hand sculpted, costing $200 a piece. He was only going to do 35 of the specialty knife series. So what we did is we scanned it, we reverse engineered it, we put the reptile skin on it, and we 3D printed them, and it only cost him $45 a piece to do the entire project. He's only doing 35 of them. It would have cost him $5,000 to $6,000 to get one mold made, and we just printed his entire line of knives that he offers a special edition.
Well, you look at the chain, like it used to, like when you would get something printed, they had to tool and die and do all this different stuff.
Absolutely.
And it's like you can change from that to this, and it's just changing the program.
Just changing the file
and
that you're
changing
designing on your CAD
the
software.
materials.
So on this particular knife, when we created it, and we created it off his original, he noticed that it was actually touching one of the clips on the knife. I fixed the notch in just a few minutes, and reprinted another one, sent it to him. Next day he goes, fit perfect, great.
Go at it.
Go at it. So in an entire process where you have to fix the injection mold, and it would have been weeks.
That is amazing.
It's the new way that everyone in the future is going to manufacture.
Yep.
It is rapid prototyping that's extreme. It's the faster, smarter way to actually build the products you want, whether it's jigs and fixtures for your assembly line, or it's end-use parts, or if it's food.
Well, the funny thing is, there were some of these machines that I think you were telling us previously when we were at the SculptCAD office, that these machines will print multiple materials simultaneously, and of course, like an infinite number of colors. So how far away do you think we are from the day when you could have one of these machines mixing things like metals and plastics, and stuff, and so that we would literally, instead of going to the store and buying a product, it's like a Star Trek replicator kind of thing, maybe even for just very simple kind of products. How far away do you think we are from something like that?
Well, right now, with Stratasys printers, you can actually use some of our printers to print things, and then you can physically insert other objects in them. But the day down the road where we're mixing metal and ceramic and plastic all together at one time, I can see those machines being built in the not too distant future.
10 years, 20 years maybe?
I think the technology could be there now to build that type of machine.
At exorbitant cost.
Exorbitant costs. Metal machines start at $1 million and up. The machines are there now. Different companies have the patents and things like that, but the day is going to come when we have those types of machines, and it's going to come a lot faster than anyone thought.
And the great thing about 3D printing, a lot of people don't realize it was invented in the mid-'80s. And the reason that all these consumer-level 3D printers have come out is because patents only last 20 to 25 years. All those are expiring, so it's opening up the market for the small guy in the garage that likes to tinker and build things, going, hey, I've got an idea for a new material, whether it be foam, and there's people using wood fiber products, all to 3D print with. It's opened that up where guys can actually experiment, not have to worry about infringing on patents, and it just increases innovation.
It drives innovation.
Awesome.
You know what I want to know?
What?
Is how long it's till we can actually save thousands of dollars a month by creating a 3D gummy bear printer.
That is one that I would buy for sure.
I know,
Yeah.
and it would save a lot of money.
All right, guys. Thanks for joining us for this particular episode of Geek Beat. Stay tuned. We got a lot more 3D discussions. If you head over to geekbeat.tv/3DPalooza, thumbs up on YouTube, and we'll see you guys later.
Thanks. Guys.
Okay, so I'm scanning you, and you can see
On yellow.
you're yellow and green.
And so inside of Recap, we did some editing and cleaned all that kind of noise out.
Point cloud. What exactly does point cloud mean?
This is a point cloud, okay? In fact, all these panoramic views become a point cloud that you can navigate in.
Oh my goodness.
Oh, that's what a point cloud is.
This
Look
is
at
a
that.
point cloud, okay? So